Before we jump into the statement, it's essential to comprehend the significance of what we are talking about. The Huge Hadron Collider, LHC, overseen by CERN, represents a stupendous forward leap in the field of science. Extending across 17 miles, this perplexing organization of superconducting magnets isn't just the largest, but also the most impressive atom smasher ever constructed. It stands as a demonstration of human resourcefulness and the exceptional accomplishments we've made in the domain of scientific discovery. Amazingly, the LHC is so powerful that it can reproduce conditions likened to those that existed at the birth of the universe. Yet, as we venture into the vast spread of the universe, we must ask, could this machine, which looks to reveal the most profound mysteries of existence, also open us to unexpected risks? Founded in 1954, CERN is arguably one of the most respected scientific research organizations on the planet, with 23 member nations and an extensive network of specialists. It serves as a central hub for cooperation and groundbreaking discoveries. While the LHC is its flagship project, it is only one piece of an expansive range of particle accelerators and experiments. Think of it as a track, not for vehicles or horses, but for subatomic particles racing against each other in a high-stakes trial of speed, accuracy, and the very nature of existence. Inside the LHC, protons are accelerated to speeds approaching that of light, duplicating the energy levels present at the time of the Big Bang. The crashes resulting from this acceleration generate temperatures far surpassing those in the Sun's core. A series of magnets direct the protons on their paths, while advanced cooling systems keep the magnets at temperatures lower than those in space. These effects are deliberately set to occur at 4 separate locations around the accelerator, where specific detectors, ATLAS, CMS, ALICE, and LHCb, collect data. Each detector plays a unique role, offering distinct views on the outcomes of these high-energy collisions. Together, they function as massive cameras, capturing the aftermath, with researchers carefully sifting through the debris to identify elusive particles, like the Higgs boson, often called the God particle, and other anomalies that could shed light on the universe's structure. By focusing on the subatomic, researchers aim to gain insight into the very fabric of the universe. However, every discovery made at the LHC raises even more questions. The LHC is more than just a scientific tool. It represents humanity's unwavering curiosity and quest for knowledge. It mirrors our drive to understand the forces that govern our reality. Yet, as we push the boundaries of the unknown, we must also face the moral and existential dilemmas that accompany it. What dangers might arise from probing too deeply into the unknown? Could our quest for knowledge unleash powers beyond our control? At CERN, where the limits of human comprehension are pushed to their extremes, a disturbing realization has become known, one that has sent shivers down the spines of even the most experienced scientists. Brian Cox, a former CERN specialist and a well-regarded figure in particle physics, recently made an unsettling statement that has both intrigued and disturbed people worldwide. Cox revealed that the LHC's purpose is to mimic a miniature Big Bang, a small-scale version of the very event that created our universe. He went on to explain the immense potential of the LHC to reveal pivotal discoveries, such as uncovering the secrets surrounding dark matter, a substance that makes up a huge portion of the universe. The possibility of harnessing the fundamental forces of the universe is, of course, dazzling, but it also comes with its own set of risks. The miniature Big Bang is not just a hypothetical concept. It is a real phenomenon occurring within the LHC. The collider recreates conditions of extreme intensity, pressure, and energy, reflecting the very environment at the dawn of the universe. It's as though we are witnessing the birth of time itself. However, with such immense power comes great responsibility. What if something goes wrong? This concern is not new. In 1978, Russian physicist Anat Borsky encountered an incident that radically changed his life. While working with the U-70 synchrotron at the Institute for High-Energy Physics in Protvino, Russia, a malfunction caused a proton beam to cross his path. The beam, traveling at an incomprehensible speed, punctured his skull, entering from the back and exiting through his nose. Though Borsky was struck by a flash of light brighter than 1,000 suns, he remained conscious and walked to receive medical attention. The result was both remarkable and disturbing. He lost hearing in one ear and suffered partial facial paralysis. Despite the severity of the injury, his mental faculties remained unaffected, and he continued his scientific work. Borsky's experience serves as a grim reminder of the power and potential risks of particle accelerators. The dangers associated with a particle smasher, like the LHC, should never be taken lightly. Concerns about unexpected reactions that could alter the very fabric of reality have led some researchers to worry about the potential of creating a miniature black hole within the collider. Black holes are regions of space where gravity is so intense that not even light can escape. These destructive forces lurk at the edges of the universe, and the possibility that the LHC could create even a small black hole is both awe-inspiring and terrifying. Could such a black hole eventually grow uncontrollably, eventually consuming the Earth from the inside out? CERN scientists have reassured the public that any black hole created would be highly unstable and would disappear very quickly. Still, the remote possibility of such an event has sparked widespread debate and concern. To understand how the LHC could potentially create a black hole, we first need to examine the basic operations of a particle accelerator. When protons collide at nearly the speed of light, the energy released is so immense that it can distort the very fabric of space-time itself. Imagine a tightly stretched trampoline with a heavy object dropped onto it. The fabric bends, and if the object is large enough, it can create a well so deep that anything nearby is pulled into it. This analogy offers a glimpse of how the LHC could impact space-time at a quantum level where the laws of physics become strange and unpredictable. A hypothesis has been proposed suggesting the existence of additional dimensions beyond our familiar 3 dimensions of space and one of time. If these extra dimensions exist, the LHC could potentially tap into them, possibly creating a gravitational well that forms a small black hole. The possibility of this happening has drawn the attention of prominent physicists, including the late Stephen Hawking. In his work, Hawking cautioned about the Higgs boson becoming unstable at extreme energies, potentially triggering catastrophic events such as vacuum decay. Sir Martin Rees, a renowned astrophysicist, also raised concerns about the LHC's experiments in his book on the fate of humankind. He acknowledged that while the chances of such an event were low, even a small probability warranted careful consideration. A lot is at stake, and the margin for error is razor-thin. Despite the extensive safety measures and reassurances from scientists, the LHC continues to provoke discussions about its potential to alter the fabric of reality itself. The collider's ability to probe the deepest mysteries of the universe undeniably brings with it both thrilling possibilities and profound uncertainties. As it pushes the boundaries of science, it also challenges our understanding of existence, the laws of physics, and even the nature of space-time. As much as the LHC symbolizes the pinnacle of human scientific achievement, it also represents a stark reminder of our limited control over the forces we seek to understand. The risks, however small, highlight the tension between exploration and caution. Every step forward in our pursuit of knowledge comes with an inherent responsibility to consider the consequences, especially when dealing with forces that are beyond our full comprehension. The potential to unlock secrets about the universe, whether it's understanding the origins of dark matter, exploring the nature of gravity, or perhaps even discovering hidden dimensions, captures the imagination. Yet, with each discovery, new questions arise, and the LHC becomes a focal point for philosophical debates about the ethics of scientific experimentation. Should we, as a species, continue to push forward in search of knowledge if it risks opening doors to unknown and possibly uncontrollable consequences? Ultimately, while the LHC stands as a testament to human ingenuity, it also serves as a metaphor for the broader human condition. Our endless curiosity, our desire to explore the unknown, and the profound responsibilities that come with such a quest. Scientists at CERN continue their work with the utmost care and diligence. but they are also aware that the answers they seek might reveal more than they bargained for. In the end, the LHC's legacy will likely be defined not just by its discoveries, but by the conversations it sparks about the intersection of science, ethics, and humanity's place in the vast, mysterious universe. Whether it will truly open new realms of reality or reveal the deep mysteries of existence, only time will tell. But for now, it stands as a bold testament to humanity's unyielding thirst for understanding, tempered by the awareness that the greatest discoveries often come with the greatest risks. Of the potential dangers, they have taken each safeguard to guarantee the well-being of their analyses, and they constantly monitor and survey their work with the most significant level of constancy. The potential advantages of their exploration, for example, revealing the mysteries of dark matter, finding new particles, and extending how we might interpret the universe, are truly noteworthy. These breakthroughs are a critical leap forward in human knowledge, yet they come with inherent risks. Like all great scientific advances, the LHC's trials present significant moral inquiries. Could the making of colorful particles or the investigation of extreme energy conditions trigger unanticipated ramifications for our planet, or, in any event, for the actual fabric of reality? These are questions that can't be messed with and should be carefully considered in the context of the broader ramifications of scientific advancement. In conclusion, the Large Hadron Collider is a great accomplishment in human creativity and curiosity. It has already led to pivotal discoveries in particle physics, shedding light on the universe's fundamental functions. However, as we explore these strange domains, we must remain cautious and aware of the potential dangers involved. The quest for knowledge is perhaps one of humankind's most ambitious endeavors, but it isn't without its challenges. The LHC remains at the very forefront of scientific investigation, where theory meets experimentation, and where the underpinnings of our understanding of the universe are being tested. The journey of discovery is never without danger, and the LHC is no exception. It stretches the boundaries of physics, attempting to reconcile the major forces of nature and answer age-old questions about the origins of mass and the nature of dark matter. Yet, as we continue to explore these frontiers, we must consider the significant moral and existential dilemmas that arise from harnessing the forces that govern the universe. The risks of potentially negative outcomes, whether for our planet or for the fabric of space-time itself, remain a challenge that demands thoughtful reflection. Nevertheless, the pursuit of knowledge remains one of humankind's most honorable endeavors. The LHC's trials, while dangerous, offer us a brief glimpse into vast, unexplored domains of science. As we stand near the very edge of discovery, we must approach the journey with both ambition and caution. The LHC represents not only the zenith of human technological achievement, but also a useful tool that can reshape our understanding of everything from subatomic particles to the most grandiose cosmic phenomena. With each forward leap comes a new wave of questions, opening new paths of investigation and thought. The road of scientific discovery is uncertain, but it holds the promise of breakthroughs that could redefine our understanding of the universe, our place in it, and the very laws that govern reality. Perhaps one of the most significant aspects of the LHC's investigations is the convergence between theory and reality. For a long time, physicists have wrestled with the forces that shape the universe: gravity, electromagnetism, the weak nuclear force, and the strong nuclear force. The ultimate goal has always been to unify these forces into a single coherent framework, a theory of everything. The LHC has played a crucial role in providing both experimental evidence and insights that bring us closer to this elusive goal. Its work not only advances our understanding of particle physics, but also holds the key to unlocking the fundamental truths of existence itself. The moral dilemmas associated with these experiments are significant, yet the quest for knowledge has always been fraught with risk. However, when those risks involve altering the very fabric of existence, the stakes become much higher. Could a single experiment at the LHC unintentionally trigger a phenomenon we do not yet understand, leading to outcomes that are impossible to predict? This is a question that scientists, philosophers, and ethicists alike continue to explore. As we delve into these unknown realms, we must remember the responsibility that comes with wielding such immense power. Regardless of the potential risks, few would argue against the pursuit of scientific progress. The rewards, new technologies, medical breakthroughs, and a deeper understanding of the universe are immense. The discoveries made by the LHC so far have already changed the landscape of science, from the identification of the Higgs boson to advancements in our understanding of dark matter. These achievements have far-reaching implications, not only for physics but also for other fields that rely on this fundamental knowledge. As we continue to push the boundaries of possibility, the LHC serves as a reminder that science is never without uncertainty. No experiment is completely risk-free, and the LHC, as remarkable and powerful as it is no exception. But with every risk comes the potential for great discoveries. The LHC is a symbol of humankind's unwavering quest for knowledge, a journey to answer the questions that have puzzled us for centuries. Ultimately, it is this curiosity that drives us forward, the desire to understand the universe, to peer into the depths of existence, and to uncover the forces that govern everything from the smallest particles to the largest galaxies. The LHC may carry risks, but it also represents the pinnacle of human achievement in particle physics. It is a tool that enables us to explore the most profound questions about existence, challenge the very laws of nature, and seek answers to the mysteries that have eluded us for centuries. Whether the LHC leads to the discovery of new dimensions, opens doors to alternate realities, or triggers unanticipated phenomena remains uncertain. What we do know is that it is one of the most powerful instruments ever created, capable of revealing secrets about the universe that were once thought to be beyond our reach. The potential for discovery is limitless, and as we delve deeper into the unknown, we are reminded that science is a journey, one that requires both ambition and responsibility. The tests at CERN continue, and we must remain mindful of the possibilities, the risks, and the tremendous potential for new understanding that lies ahead. The LHC, while embodying the cutting edge of modern science, is also a reflection of our deeper quest for meaning and understanding in an immense and mysterious universe. Each new discovery brings us closer to a fuller understanding of the forces that shape our reality.